Hello, my name is Aaron Bowman and I'll be your instructor for this lecture. I'm currently a postdoctoral fellow in the Carolina Health Informatics program and conduct research focused on using machine learning to improve medication adherence. Today we will discuss CSV files and how to deal with null or implausible values. CSV stands for comma-separated values and represents a table with commas and text showing the division of data into columns. These two images both show the exact same data. On the left, the data is housed within a table, and on the right, the data is being presented in a CSV format. For the remainder of the course, we will be using data analytics software called R. R is designed primarily for statistics and is one of the most popular tools for data analytics. Like previous sections, we will also be using Jupyter Notebooks so that you will not have to download any software and can simply run the code that we have already provided to you. This is a screenshot of RStudio, which is a user interface that can be used to manipulate data using R. RStudio will not be used for this class, and this information is only being provided for informational purposes, in case you would like to do it on your own. For a person that is using RStudio, they would first click the Import Dataset button, and then select the CSV file that they want to read into RStudio. Next, this screen will pop up, and the user will specify how the CSV file will be interpreted in a table format. For our file, the first row is filled with column headings, so yes would be selected next to heading. Also, since this is a CSV file, comma will be selected as a separator. Finally, the user would click Import, and now the CSV file will be available to manipulate using R. Now we have to clean the data that we just loaded into R. Two very common issues that must be addressed when cleaning a dataset are null values and implausible values. In the example table on the right, cells that contain no data or NA are considered null cells. Null cells are very problematic because they interfere with your ability to manipulate the data, because they cannot be incorporated into mathematical operations. Implausible values, on the other hand, can be processed using math, but they will greatly impact your results, and therefore must be dealt with as well. In the table on the right, a heart rate of 10,000 beats per minute is obviously impossible, and if it is not replaced or removed from your data will likely impact your analysis in a very problematic way. When there are nulls within a dataset, they can be dealt with by deleting data or by inserting a value in place of the null. When a column is composed mostly of nulls, it is typically a good idea to delete this column. However, for columns that have less null values, deleting columns is not the best practice, since it will likely reduce the performance of your model. In these cases, you will want to replace the nulls with either some measure of center or a value generated by an imputation algorithm. Measures of center like mean are very easy to use to replace nulls, but should only be used for small data sets where accurate predictions of the missing values are less likely. When replacing nulls with a measure of center, it is important to consider the data type of the column in question. Numeric data has a mean, median, and a mode. Ordinal data only has a median and a mode, and nominal data, also known as categorical data, only has a mode. Also, if you are choosing between using the mean or median to replace numeric nulls, then the distribution of the data is also important to consider. If the data has an even distribution, then the mean is a good choice, but if the data has a skewed distribution, then the median is more appropriate. On this slide, I'll show you how to calculate the mean and also how to determine the median and the mode. The mean is calculated by first determining the sum of the column values, which in this case is 45, and then dividing this by the count of the column values, which in this case is 7. The median is the middle number when the numbers are arranged in order by value. In this case, the middle number is 5. The mode is determined by looking at the value that occurs the most frequently. In this case, 1 occurs 3 times and is therefore the mode. Another approach to replacing nulls is to use an algorithm to predict and replace the missing values. This method is typically more accurate than replacement with a measure of center, especially for large data sets. In the exercise for this section, we will use random forest to predict and replace missing cells. One advantage of this particular approach is that random forest can handle both categorical and numeric data. Categorical variables have data that can be divided into groups. An example of a categorical variable would be if a patient is male or female. Another example of a slightly more complex categorical variable would be the city that a person lives in. Numeric variables, on the other hand, are comprised of numbers that can be used for mathematical operations. An example of a numeric variable is heart rate, measured in beats per minute. When selecting a model, it is very important to determine if you have selected one that can handle the types of variables that you are providing to it. You should also consider the complexity of the categorical variables being provided to a model. Some models can only accept simple categorical variables like gender, while others can accept more complex categorical variables like city. Implausible values are values that do not make sense. An example of this would be a human with a negative age or an age over 120 years. Implausible values are dealt with in a very similar way as nulls. They are typically either replaced with a measure of center or replaced using a predictive algorithm. All select null values if the majority of the data is implausible, then the entire column should be deleted. Thank you for listening today, and please work through the examples provided on the accompanying Jupyter Notebook for this section.